Yeah, sorry about that. My router rebooted because it's 4 a.m. It's like, I'm sleeping. 4 a.m. I will be in bed. I can reboot my router. Yeah, think again. It's wide awake. Well, actually, it's pretty simple because I have here the match plus 4 equals 131. So, no guessing needed. But spaces are needed. Let's put a few spaces here. Oh, well. Right. And then I want to have 6. This 6 is 137. Yeah. 37. One, two, three spaces. 1, 2, 3 spaces. I have the feeling it doesn't fit. Oh, it does fit. So subtract 4, this 4 from the 137 gives me 133. And then subtract 2 gives us the 131. Subtract 4 gives the 127. So that's what these numbers mean. The 6 corresponds to the 127 and the 4 corresponds to that one, and so on. I want to fill them in. So now now I have to add 2. 139. Add 4 is 143. And then add 6, 149. 151 plus 6, 157 plus 4 is 161. Plus 2, 163 plus 4, 167 plus 2, 169. Dot. Right, and then wherever I have a plus, we have a composite, and it should be, in this case, I think this is like 65 divided by 13. I should know that, of course, but yeah, of course 5, so this must be 7. 133 divided by 7, 19. So this is 133 is 19 times 7. Yep. And now we go to the next one that is short-circuited here, this one. That's 161 divided by 7. It's 29. 29. That's pretty huge. That's huge. Okay, slightly confused here. It's a jump of 10. Don't have jumps of 10 yet. Huh? Doesn't make sense. Of course I should have a 23 in between. Prime numbers are 19, 23, 29. Yeah, so 23 is missing. 23 times 7 is 161. What? 23 times 7, 161. No idea why I have 29 there. 29 is way further. 29 times 7 is 203. Yeah, it's way further. Okay, so then complete my ASCII art here. That is +2. And here we have +4. Oops. No. I have to figure out where that comes from. So yeah, so what we do is we have like I think it's just 49 plus 4 is 53. The +4 is simply continuation of this series 4242. And here I have 121 plus 6. And that is then, I hope, a continuation of where we were left off here. So I have here like 6 to 6, 4 2, 4 2, 4 6 to 6. That is just this thing repeated. So we were left off at this +2 here. Then we get that +6. So we get 127. And then yeah, then I keep adding the next one. So this was, we are here. I know we are here because you're generating these numbers. I just continue with it. Going this way. That's a +4 to go there. Can draw that one in as well then. Okay, so here we have just +2. This is my square. Okay, I wrote it in like that. +2. Okay, so here we have +4. Didn't wrote that in here because it's already there. Yeah, this is just a map to see what's going on, but no, it's still +4. I mean, it's the same +4 as that one, but so this +4 is kind of that +4, and therefore not necessarily the same. Like this +2 is unequal to this +4. So maybe I should make yeah, I should add it here, I think. So +4 is 53. And that is just going there. So here we have a +6, which gives 127, which goes there. Oop, oop, oop. Yep. Now this series here, this is plus 2 plus 2 plus 2 plus 2. This is plus 4 plus 2 plus 4 and so on. So this one. Repeated, they are not prime numbers, so we do get to the 25 and I might actually need that. So this is going to be a class and that's going to produce these numbers. I'm just slightly confused why I would start with a plus 4 here, or rather how I know that. I guess it's easier to see when we get something that is more complex, like here. This is also plus 2 plus 4. Let me think. I think these numbers are 7, 11, 13. So it's already skipping 2 things. I think these are numbers are not divisible by 2 and 3. So let's add that here. Divisible 2 and 3. Yeah, so the plus 4 here comes from the fact that 9 is, well, 8, 9, 10 are all divisible by 2 and 3. And 11 is the first one that isn't. But of course, I don't want to calculate that, so I just need to get that plus 4 from somewhere. Anyway, I want to add that here as well. Yeah. 2, 3, 6, 7, 8. Yeah, this is these numbers. No. These numbers here. Not divisible by 2. So that would be the 5, 7, 9, 11, 13 and so on. Just add 2 every time. Then likewise we have here these numbers. And they would be the ones that are also not divisible by 5. I really have to make this a little bit longer, I think, in order to see what's going on. This one already had to be very long. This one has to be insane long before you can see it, but well, shall we do it? Guess I have to. So we have 6, 4, 2, 4, 2. After the 6 to 6, 6 to 2, 4 to 4, 2, we start again here. So that's the plus 4. Is that correct? I think so. 4 to 4, 2, yeah. So plus 4. It's probably easier to fill it in here first. 1, 2, 3 spaces. So I start at the beginning, that's 4 again. Yeah. 1, 2, 3, 6, 1, 2, 3, 2, 1, 2, 3, 6, 1, 2, 3, 4, 1, 2, 3, 2, 1, 2, 3, 4, 1, 2, 3, 2. I've got a space here. No, so we have more space. So 1, 2, 3, 4, 1, 2, 3, 6, 1, 2, 3, 2, 1, 2, 3, 6. No. Try that first. Maybe long enough. So now I have to add 4 to that number here. So 169 plus 4 is 173 plus 6, 179 plus 2, 181 plus 6, 187 plus 4, 191 plus 2, 193 plus 4, 197 plus 2, 199 plus 4 is 203 plus 6 is 209 plus 2 is 211 plus 6 is 2170. And now we need to find all numbers that are divisible by, I forgot it again, 7 I think. 161 divided by 23 is 7. Yeah, it's 7. What is the next number that is divisible by 7? Probably 29 times 7, but 203. It's all the way here. All the others are not divisible by 7. Okay, I'm gonna try that out like as follows. The 75 is not here. 189. 189 is not here. I just add 14 every time. Oops. 203. Yeah, well, okay, that's 203 it is. So we have here 39. Which makes this an incredible offset of 10. That is seriously confusing me. 10. Shit. I don't have a 10. Not here, not yet. By being so stupid that I miss a prime number between 23 and 29. I sure hope not. Nope, 23, 29. That's a big gap. It's a gap of 6. I don't know, I think it's 4 AM and I have to go to bed. I thought 29 minus 23 is 10. That's about the moment that you say, okay guys, I go to bed. Plus 6, 10. Complete idiot. Scary. And still I don't know anything, of course. I mean, 2, 4, 6, you have that everywhere. Where the hell does that come from? Well, from these numbers, of course. No, not divisible, that's the thing. Not divisible by. So these things just come from that they are not divisible by. 2, 3, 5. 5. And then it didn't fit anymore. The next one is going to be 31, of course. 31 times 7. 217. I even have that one. Right. I can make this one longer. So that becomes plus 4, plus 6, plus 2, 6, plus 4, plus 2, plus 4, plus 2. Finally we have a plus 10. Boy, nearly. Plus 2, plus 6, and so on. Hello, Mark. I think I actually did it. I think I did it. I think I found a way to generate primes like faster than the C of Aristotle's. This is just working out kinks. But okay, let me see. Oh, I did not make a mistake here. Looks good. So now let's see if my magic formula works for the next block here, which is pretty small, I must say. Nevertheless, the main problem was before that I had absolutely no clue where my first number came from. But now we see that here. Let's say it's that plus 4 here. Well, that's the first number. Yeah. It's, yeah, of course. So this is the continuation of that. So I just, this here is the continuation of that. Wait, so I have 2, 4, 6 to 6. That 6 is this 6. And now we continue here. So, if I do that here as well, I get 1 plus. So, I need to know where I am, and I am, of course, exactly here. So, I mean, this 6 is that 6. So, 6, 4, 6, 2, 4, 6, 2, 2, 6 is 4, 2. 6, 6, 4, 2. So, I'm at here, plus 4. And that gives me 169 plus 4. 169 plus 4 is 173. Yeah, of course. That's the thing below there. And we can fill that one in then here. .173. Just like here. And then I have to continue like that, so probably like that. as in this was that 4, just like this 6 is that 6. 1, 2, 3, and then we continue with the same thing. So this 4 was 6, 6, 4, 2, 4. So now I'm here. So we get this continuation here. And I don't know what follows. And at least I didn't write it down there, up there. Okay. So down there, the numbers that belong to that are 181 plus 2, 183. That's not correct. Plus 2 is 181. Plus 6 is 187. Plus 4 is 191. 193 plus 4, 197. Plus 2 is 199. Plus 10. 29 plus 2, 211 plus 6, 217. And we don't know what comes next. We are going to look for the things that are divisible by 11. Because this one was 7, right? The next one is 11. What is 11 times something? So 173 divided by 11 is 15. 16 times 11 is 176, which is not here. What number 16? Of course, it's going to be 17. 17 times 11. 187. That one. So there's a 17. Oh, what the hell? Undo. This is 17. Yeah, I could have known that because it's this 13 here. That continues by adding 4. It becomes 17. And that is because we have all numbers that are not divisible by 2, 3, 5, and 7. So the next number after 17 that is not divisible by 2, 3, 5, or 7. It's probably a prime number. It's going to be 19. 19 times 11 is 209. It's going to be here. 19 times 11. Seems again an enormous jump. Why is it not much closer? It's already a jump of 10 here. The distance is 4 plus 2 plus 4 plus 2 plus 10. So that's 36. Must be 22. Did I do something wrong? Times 11, 187. 19 times 11, 209. Four plus 2 is 6 plus 4 is... Oh yeah, it is 22. Okay. Now. Plus 2. Next one is gonna be 23, of course, so plus 4. And now we end up at 1923 times 11, 253. But I don't know exactly how that works, so yeah, well, whatever. Now line this one up. So this one got short-circuited and that one too. Because of this. So the 10 gets there. That's 10 is 6 plus 4 is 10. 2 is 2, 4 is 4, that 2 is 2. And the 12 is 10 plus 2. So apparently the next one is 4. And this one must be short-circuited. What? Oh, that's not good. Okay, now I'm confused. It's not short-circuited. Why is there a 10 here? This tells me that it just should be 6. It should be 6. Uh-oh. Definitely plus 10. I wrote a program to generate these numbers, so they are correct. But now I don't understand where my plus 10 comes from. Sad face. How is this possible? Okay, we're talking about 217. How did they get to 217? 2 is 2 plus 6. Yeah, totally 217. Now where did the 6 come from? It is 6, yeah. That 6 is just this 6. And that should not be there because it is a short circuit. I did it wrong. Where's my cursor? Here. This is 217 is divisible by 31. Apparently, yeah, 7 times 31. So this is a short circuit. Let's add one more. This one is it one longer. Six to six. Just repeat. So the next one is 4, I guess. Plus 4 is 2, 2, 1. Does it look like a prime? Is that a prime number? 2, 2, 1 is not a prime number. But maybe it is not divisible by 2, no, and not by 3, indeed, and not by 5. But we're talking about these, so yeah, then that cannot have a factor that is in here. 13 times 17 is just too large. So that stays probably. Belongs to an offset of 4. And then this one becomes 6 plus 4 is 10. Yep. So that would be here. So this now must be 10. And then we get at 2, 2, 1. Yeah. And then we can align it. Plus 10 again. Ew. Saved by the typo. Okay, I believe the rest. The thing is, now I should be able to generate this, right? The thing is that every time we have a horizontal line here, I start a new object, and the object must generate these numbers. I already know how to detect the expected failures here, but I still needed to figure out the optimal way to find these numbers. Well, I just listed them here as well. And the way we can find that is by repeating these numbers, which are just these numbers, which we have at that moment. These numbers are known, and they start here, 462, 462. We go down, and then we go here, left, and we just continue. And then I can deduce what these numbers are, because every now and then we reach a number which is predictable. Wrong, namely, I know that 133 is the first one that's going to be wrong, because 133 is 19 times 7, and I know we're dealing with 7 at that point. This 7 here, and we know the 19 because this is just prime numbers. Well, actually not, but yeah, it's a bit vague. It's a bit vague. I tested it till like a million prime numbers, and it was always a prime number. But maybe it's kind of coincidence, so I'm not sure yet. I mean, this one's not a prime number, so I think I have to to be careful. I mean, as long as whatever appears here are prime numbers. But then if we go horizontal here, then you end up with something that's not a prime number, and that might be significant. I mean, I need this 25, I think, to detect that the 125 is not a prime, which means that this plus is being there, which caused me to add those two up, which is not relevant in this case because this one repeats way earlier, but at the larger values that might become relevant, so I don't know yet. Anyway, I can just ask that object. I have an object that generates integers that are not divisible by 2, 3, and 5. So then we can get 17 from there, and then the 19 is just the next number, and so on. So just we found 133, then we know the next number is 23. Times 7 is 161. So then I just add these things up, get to there, combine those two into the next, and so on. Just addition and comparing. Well, it should work, but I really have to go to bed. It's almost 5 a.m. It's starting to be ridiculous. Only thing I can show you is like if I run this program. The thousandths prime is 7,919. Well, it's fun, but let's say I want to have the 1,000,000th prime. 2, 3. Probably a bit too much output if I do that. Let's not print. Okay, should work. I hope. Oh, I think I missed some output. Oh, was already done. Oh, let's run that again. Yeah, it's pretty fast. So the 1,000,000th prime number is that, and that's correct. That's pretty damn fast, right? I mean, if you look at the output, that is linear with the number of calculations it's doing. So it's like, wow, fast. I wonder if it can do even more. At some point it should slow down though, because I have some really slow code in this still. This is just a test. We're being this loop here, that's slow. So I'm going to get rid of that, of course. Let me try to find the 10,000,000th, and then I go to bed. The fun part of this program is that it just doesn't use a sieve at all, actually. It just generates prime numbers. No sieve. It starts immediately, generates primes, and that's it. I don't have a sieve here. See some pretty big gaps, sort of like plus 200 something. These are what it prints are just still the gaps between primes. So does it mean that it's going to print 10 million lines now? Still a little bit too much debug output then. Contemplating stopping it. Yeah, well, 1 million was pretty fast, so I don't know. No, there it is. 1 millionth prime, 10 million prime. Submit. That's the answer. And that's correct. Ain't that awesome? But I'm going to bed, to sleep even. I'll continue tomorrow.